Okay, solving equations. Solving equations is going to be one of the most important topics we deal with in Algebra 1. We're going to be solving equations in one form or another, essentially for the rest of the year. Okay, and a lot of people can describe algebra as, if you could describe algebra in a phrase, it'd be solving for x. Okay, that's what most of algebra is. We're rearranging equations to try to get the variables by themselves and figuring out what the variable represents in a given equation. So solving equations is very, very, very important. We're going to start with the basics today. Most notably, what's the goal of solving an equation? I mentioned it a little bit already. Our goal for this process is to figure out what the variable represents to make the equation true. So we're going to find the value of the variable that makes the equation true. And now some of these are easy, and we're going to start with the easy ones. But some of them you can figure out in your head. What plus 2 gives you 5? Okay, well, you should know that 3 plus 2 gives you 5. So that variable would have been 3. 3 plus 2 is 5. So that's our goal. We're trying to figure out how to make our equation true if we would plugged in a value for that variable. A more kind of basic form is we're trying to get the left side of an equation to equal the right side. Okay. Remember that an equation is more of a sentence. Okay, so you're trying to kind of complete that sentence. The left side is something, the right side is something. That equal sign says that they're true. So you have to figure out what that value is that's going to make it true. All right, well, what's the process for solving equations? The process is we're going to be trying to isolate the variable. Okay, so isolate means to get, completely by itself. Okay, isolate the variable and isolate one occurrence of the variable. So in some of these, in the beginning ones, we won't have it, but eventually there's going to be more than one variable. So we're going to have to get all those variables together and then isolate it. Isolate just that variable, just the unknown, whether it's x or a or whatever variable, get it by itself. All right, how do we do that? Well, there's going to be some steps. First thing you're going to want to do, and again, not all these steps are going to apply right away, but we might as well lay out the entire process. First thing you're going to want to do is you're going to want to try and simplify each side as much as possible. So what does that mean? Well, it could mean, maybe distribute, or, use order of operations, or use some of the properties to rearrange things to try to get each side as small and concise as you can. Okay? So if there's combined like terms, maybe there's like terms. If there's like terms, you're going to want to combine them. Okay? So simplify each side as much as possible. Okay, again, could just be adding and subtracting numbers together. It could be combining like terms. It could be using distributive property. As much, I can't write and talk at the same time, as much as possible. All right, well, once you're done with that, you're going to want to gather all the variables to one side. Usually people like to go to the left side with the variables, but again, because we know the symmetric property, the left side and the right side are equal and are interchangeable, so it doesn't matter what side you go to, but gather all the variables to one side. And everything else, everything that's not a variable, which means it's probably going to be a constant. Now, there are cases where it might be another variable, but at the beginning here, it's just going to be a constant. So we'll say constants for now. But just know that it's not necessarily always a constant. So if the variables are on one side, everything else is going to the other side. All right, and then finally you're going to be using and again, this is kind of step 2, really. If you're gathering all the variables to one side and moving the constants to the other side, you're going to use this step to do that. Okay, so you're going to use inverse operations to switch sides. So again, that's kind of part of step 2. Use inverse operations. So we know what inverse operations is because of the properties we talked about: additive inverse, multiplicative inverse. The additive inverse and the multiplicative inverse are, how do you get the number to not change? Okay, so in the additive inverse, you add 0. So adding 0 to something doesn't change it. In the multiplicative, you're multiply by 1. Multiply by 1 doesn't change the result. Okay, that's our goal here. If you got an adding or subtracting problem, you're trying to get to 0. If you got a multiplication or division problem, you're trying to get to 1. So the inverse operations, you can think of it like this, that if you are trying to get rid of an addition, you're going to use a subtraction, and vice versa. If you need to get rid of a subtraction, you use an addition. Okay. Now really what you have is you have positive and negative numbers. And for a multiplication, if you need to get rid of a multiplication, you're going to have to use a division. Now again, multiplying by a reciprocal is the same thing as dividing, so that's why they're the same. And adding an opposite is the same as subtraction. Okay, so they're all tied together here. So if you got an addition, use subtraction. You got subtraction, use addition. Multiplication and division, same thing, vice versa. Okay. Some key things to remember when you're doing this. I'm actually going to erase this step 3. It's bothering me. Because again, that whole thing is basically one step. Okay. What order do we go in? We're actually going in reverse order of operations for the most part. In most of these problems, you are going to be adding and subtracting first, and then multiplying and dividing separately. Not separately, but next. So generally, it's a reverse order of operations. Okay, and you'll see why when we go through the problems, because you're trying to break these down piece by piece. And the second key thing to remember when you're doing these is that anything you do to change one of the sides has to be done to the other side. So anything done to change one side has to also be done to the other side. Okay, because we need everything to be balanced. We need the left side and the right side to always stay the same. So if you're going to add 5 to the left side, you also have to add 5 to the right side, so that your equation doesn't change. Okay, the key concept of that doesn't change. It's just a balanced equation. Okay. You can't do something to one side to change the left side and have it still equal the right side. Okay, we're going to start with one-step equations, or one-steppers. One-step equations, as the title suggests, can be solved with just one step. So remember the goals here. We need to isolate the variable. So the first thing we have to do is to identify the variable, find it. Okay, so in this first one, and again, if you want to pause the video and try these 4 and make sure you get them right, I think you should do that. But we'll go through this now. Find your variable. There it is. That variable, that x, needs to be the only thing on that left side. Well, what else is on that left side? On that left side is a -7. We need to move that -7 from the left side to the right side using the inverse operations. It's currently a -7, so the opposite of taking away 7 would be adding 7. Okay, and we just write it right below it. So we're going to add 7 to the left side. Okay. Now remember, anything we do to the left has to be done to the right. So we're going to add 7 to the right side as well. Okay. Now I want you to be careful when you're doing this. We're going to cross this out. Okay, why do we cross that out? Well, it's because negative 7 plus 7 is 0. So really, we're not getting rid of it. Really, it just becomes 0. But we know that anything plus 0 stays the same. We don't need that plus 0 anymore. Okay. So we just cross it out. But again, make sure it equals 0 before you cross it out. So don't just cross things out because you think you should. Okay. We cross it out because negative 7 plus 7 is 0. All right, so now x is by itself. And what does x equal? Well, x equals the right side. The right side is 7. There's 8 plus 7, which is 15. So x equals 15. Again, easy. One step. Well, second one. Second one is x over 3 equals negative 7. Now remember, in algebra, we use the division. Instead of using the division symbol, we use a fraction. Okay. So we find our variable. And it's x over 3, which is the same as x divided by 3. To get rid of a division, you use multiplication. Okay. I like to think of it as like I'm trying to rescue a princess up in a tower, and I got to get rid of the tower first. I got to knock down the tower. So I'm going to throw a fireball at the tower. A multiplication fireball at the tower gets rid of the tower. Okay? Because really this is 3 times 1/3, which is 1. Multiply by the reciprocal. So 1 or 1x is just x. Alright, so we knock down the tower. The princess falls to the ground by itself. It's just x on the left side. That's what we want. Well, what's on the right side? Negative 7. But remember, if that fireball went to the left side, the fireball also has to go to the right. So we got multiply by 3 on the left, knocks down the tower. Multiply by 3 on the right, you get negative 7 times 3, which is negative 21. The third one, 1/2 x equals 15. 1/2 x, 1/2 times x equals 15. All right, obviously I need to get rid of the 1/2 part. Now you got two options here. It's 1/2 times x, so you could divide by 1/2. Okay. You could also use the multiplicative identity. Instead of dividing by a half, you can multiply by the reciprocal, and the same thing's going to happen. So the reciprocal of 1/2, remember if you have the reciprocal of a fraction, you just make the top the bottom, and the bottom the top. You just flip the fraction over. The reciprocal of 1/2 is 2. Okay. 2 times 1/2 is 1. Okay. So that crosses out, leaving behind the x. Okay. Now again, you throw it on the left side, you have to throw it up on the right side. 15 times 2 is 30. X equals 30. Now the fourth one's kind of a trick. It's not really a one-step equation. It's like a 1.5-step equation. Okay. The reason for this, and this is, again, tricky. People see that minus sign, 7 minus x equals 12. They see that minus sign, they're like, all right, I have to do the opposite of minus, which is plus. Okay. And this is what we'll do. We'll do, all right, I'm going to add 7 on both sides. Cross that out, and you're left with negative x equals 19. X equals 19. Great, easy, one step. You actually can't do that. Why can't you do that? Well, because if you try to do that, you try to add 7 to both sides. 7 plus 7 isn't 0. 7 plus 7 is 14. So you wouldn't be able to cross that out. Now, you could add 7 to both sides. You could add 100 to both sides. As long as you do it to both sides, you can do whatever you want. But it's not going to help us solve the equation. And the reason for that is because that 7 is positive. Okay, that minus, which you see, visibly in the middle, that minus goes with the x. Okay. So it's really positive 7 and negative x. Okay. So positive 7 and negative x. To get rid of positive 7, you're going to have to do minus 7. Okay. Now you can cross it out because positive 7 minus 7 is 0. So again, remember, the sign to the left stays with that number. All right, and then we subtract 7 on the right side, you get 5. Now on the left side, you don't have x. X is not isolated. Because we don't have x, but we have negative x. We don't care about negative x. I'm sure it's a great variable, but we don't care about it. We want to know what positive x is. Okay? So positive x, if you have a negative x, you want to make it positive, you can, mathematically what you're doing is you're multiplying by -1 or you're dividing by -1. But in practical use, all you're going to do is you're going to flip all the signs. So if negative x equals 5, that means positive x is going to equal -5. So you just change the signs. Now if that was a -5 to begin with, it would become positive. So whatever is the opposite of it. Alright, so those are 1 steps. You can figure out what operation is being done to the opposite. Make sure you do it to both sides. And you should be left with x equals a number, or whatever variable equals a number. Now for the 2-step equations, 2-steppers. Okay, 2 steps should be your comfort zone. Now a lot of our problems that we're going to do are going to be more than 2 steps. But once you get down to the 2-step equation, you guys need to be automatic with these. Okay, it should be, you're kind of home free once you get to the 2-step setup. The 2-step setup generally has the same rules, and we'll see a case that's not there in a minute. But generally, it's always going to be an add or subtract, and then a multiply or divide, depending on the problem. So let's look at this first one. 2x plus 7 equals 27. Okay. Find your variable. Oops, too much. Variable's right there, x. We need to get everything away from that x. Okay. So again, think of it as you're trying to rescue a hostage or something. That's the target, but you need to get rid of the guards around it. So you don't start with the guard that's standing right next to it, you start with the guard that's furthest away from it. Okay, which is the plus 7. Again, think reverse order of operations. You want to add or subtract first. So we need to get rid of this plus 7 first. You always start furthest away from the variable. So we're going to do minus 7 on both sides. Okay. Again, cross out the minus 7 over there because it equals 0. So now what's left over? What's left over is 2x on the left. Again, we did minus 7 on the right because whatever you do to the left, you have to do to the right. 27 minus 7 is 20. And now we're down to a 1-step equation. 1 step, we have 2 times x. We need to get rid of that 2. To get rid of a 2 times x, you're going to divide both sides by 2. Okay. These can cross out because 2 divided by 2 is 1. And what we're left with is x by itself on the left and 20 divided by 2 on the right, which is 10. All right, another one, 2 steps. X over 3 minus 6 equals 14. All right, this one again is our hostage rescue. We need to get that by itself. We need to get that x by itself. So we're going to start with things that are furthest away from it and just kind of piece by piece chisel our way through until it's just x. First thing up is we're going to get rid of this minus 6. Okay, that one's easy to get rid of. To get rid of a minus 6, you add 6. Okay. We did it to the left side. We have to do it to the right side. Okay. Cross it out because minus 6 plus 6 is 0. On the right side, 14 plus 6 is 20. And on the left side, you still have x over 3. Okay. We had a problem like this in the 1-step section. X divided by 3, x over 3. It's the same thing. So we need to knock that hostage out of the tower. Got to get rid of the denominator. So we're going to multiply by 3. The 3 on top and 3 on the bottom goes away, leaving just the x. And on the right side, you have 20 times 3. 20 times 3 is 60. X equals 60. Now you could always check. You could check all of your answers by plugging in 60 back into the equation, figuring it out. If you plug in 60 for x, you would have 60 divided by 3, which is 20, and 20 minus 6, which is 14. So it'll always work out if you did it correctly. And this last one, I use the same numbers for all these. This one's a little different because you're not adding and subtracting first. The reason for that is because your variable is up in the top of a fraction, which is grouped together. It's part of the grouping symbols. So it's up in this group with a -6. Okay. If we're doing reverse order of operations, we're going to deal with the groupings last. So you're going to deal with the rest of this first. Okay. Same as the one above it. We're going to have to knock down this tower first by multiplying by 3. Okay. That drops down everything that's on top, which is x minus 6. And then on the right side, you got 10 times 3, which is 30. All right, now you do the adding and subtracting, because now the only thing left is you got your rescue over here. We got to get rid of that last guard, which is a -6. So we're going to hit it with a +6. Okay. -6 plus 6 eliminates. And you're left with x on the left side and 30 plus 6 on the right side, which is 36. Okay. So that's solving equations, 1 steps, 2 steps. We're going to add a bunch more steps in the future.